Hello friends, welcome to Seco. In this video I am going to show using this position time graph that the average velocity is kind of related to the slope of a line. Let me explain it. Along this line I have drawn time in second unit, and along this line I have drawn position in meter unit. Now this is the pink one. This is the actual position time graph of a particle, and we are considering these 2 points, P1 and P2. That means from time 5 second to 7 second. This is what we are considering. Okay, this is not the exactly same figure in your book, in your textbook. This is actually explained in figure number 3.4, and this is not exactly same figure, but this is conveying the same message of what is conveyed in figure 3.4. Okay, so anyway, now we have to understand the thing, understand the concept. That's all. Even though this is little different, it will not make any difference in the concept. So from 5 second to 7 second, the particle moved from 10 meter to 20 meter, isn't it? And this pink one is exact actual position time graph, and what we have done here is we have connected these 2 points, P1 and P2. That means initial point and final point of our consideration. Okay, so here the average velocity of the particle between 5 second and 7 second, what we have to do is we have to find how much distance it has traveled by how much time it has taken to travel that much distance. So it traveled this much distance. That means 20 minus 10, x2 minus x1 here is x2 minus x1 is 20 minus 10 meter. That means 10 meter, and the time taken to travel this 10 meter is t2 minus t1. That means 2 seconds. 5 to 7, that means 2 seconds. T2 minus T1, that means 7 minus 5 second equal to 2 second. So the average velocity, average velocity equal to 10 meter by 2 second equal to 5 meter per second. Okay, so here we are writing velocity and just writing 5 meter per second, and we are not giving any vector sign, but still it is okay because it is one dimensional velocity, one dimensional motion. And in case of one dimensional motion, convention is when the velocity is positive, that will mean that it is moving in the positive x direction. Okay, so if you say that average velocity is 5 meter per second, it will be okay. It will be understood that it has direction in the positive x direction. Okay, so it's okay. Now the average velocity is nothing but actually slope of this straight line P1 P2. Okay, because what is slope? Slope of any line, if we draw any line, this line, what is slope? This is x-axis, this is x-axis. What is slope of this line? If this line is making an angle theta with this axis x, then slope of this line is tan theta. Okay, this is the definition of slope. So in this case, when we have connected P1 and P2, and now you can see that it has made a triangle. So if this angle is theta, that means this angle is the angle that is making with this x-axis, because this line and that line are parallel lines, isn't it? So if you extend it, it will cut this line somewhere here and it will make angle theta. So this is angle theta. So what is tan theta here? Tan theta, that means slope, is equal to nothing but, if we call this point Q, then tan theta is nothing but P2Q by P1Q. But P2Q means x2 minus x1, and P1Q means T2 minus T1. So it is nothing but actually average velocity, isn't it? Average velocity. So we have found here that the slope of the line the slope of the line is nothing but average velocity. So this is how average velocity or average speed is connected with, in this case, average speed and average velocity will be same, isn't it? Because it is one-dimensional motion and it is moving towards positive x direction, so their values will be same. So slope is equal to average velocity. So this is what they have explained in figure number 3.4. Now we are going to explain 3 more figures. This is one. I have already explained this figure, but let me explain once again. This is position, this is time, and it is a straight line passing through origin. That means when time was 0, that means when we have started counting time, the particle was in the origin, and then after 1 unit of time it has traveled some distance, and then in the next unit time it has traveled again same distance, and in the next unit time it has again traveled same distance. So this is actually this kind of graph represents uniform motion, and the particle is moving towards positive x direction. As time is increasing, x is also increasing, so particle is moving in the positive x direction and its motion is uniform motion. And now let us go to second graph. This is another graph they have given like this. So this is x position and this is time graph, time axis. This is 0. So when time was 0, it was away from the origin, it was some distance away from the origin, and as time is increasing, x is decreasing. When time is 1 unit, x is little less than that. Initially it was there, but 1 unit time, after 1 unit time it is there. Okay, so x is reduced. So after again some time, it is again, x is again reduced, x is this much, and again after some time distance is again reduced. So what is happening here is the particle was initially some distance away from origin, it was some distance away from origin, and as time is increasing, it is moving towards origin, it is coming back to origin, and its velocity or its speed is constant. That's why it is a straight line. Okay, so it is returning to the origin and its speed or velocity is constant. And now they have not done this, but if this line goes like that, okay, it will finally touch this time axis. That means it will reach to origin, after this much time. Okay, now if we continue to do like that, if the position time graph goes like that, that means now it has crossed the origin and it has started to go to negative x direction. Okay, if this is origin, this is x, it has crossed the origin and it has started to move to negative x direction. Here you can see that after this time, in this time the x distance is negative, in the negative direction, isn't it? So it will be like that. And then we have another graph like this. This is x coordinate, this is x coordinate, and this is time coordinate, and the graph is like that. The graph is like this. Oh, this is a straight line and this is parallel to the time axis. Okay, so you can see that in this graph time is changing, but the position is not changing, the distance from origin is not changing. That means particle is there in the origin even though time is changing. So this particle is at rest. So that's what I wanted to discuss in this video. I have discussed three graphs in this video. In the next video we'll see one example and then we'll talk in detail about instantaneous velocity and instantaneous speed. Thank you for watching. Hope you like this video. If you like this video, hit the like button. And this is new channel. If you think that this channel will be creating a positive impact in your life or in some other person's life, then please subscribe this channel and please share with your friends so that it reaches to the people who really needs this. And you know, in YouTube algorithm, if you hit like button and if you subscribe this channel, then YouTube algorithm will think that this video is a good video, so they will show this video to more and more people. So please subscribe and hit the like button. Thank you for watching. I'll see you soon in the next video.